panel schedules. See if we can find in the notes if I had one. I didn't. Okay, I guess this is what we'll have to work with. So it's normally schedule, and this would be the panel board being that this is where the lights and the receptacles are connected. Other things too, small motors and a motor branch circuit, right? Could have motor branch circuits. So it's typically, or it is by nature of product listings, designed consistently, and that's why we can make these panel board schedules and use them no matter the manufacturer. At the top, there's just normally listings of the equipment ratings, and to the note of what is the contractor looking at, if that is a cookie cutter generic approach, or I've done several of these buildings and that's how they're qualified to do it whenever they were trying to win the work, potentially, if it was to be qualified, they've had this before or designed these before, is to make sure to look for where the dollars and cents are, the ones that you don't want to miss, because if you miss, it's expensive or it's a long lead time. So things like the KAIC rating, or even as the engineer of record, if maybe you had a team, one of the things you're doing, even though maybe things are changing on the projects, is you're looking at those things. You're like looking at the largest feeder sizes, you're looking at all the demand calculations, the KIC, you're looking at the things that matter the most. So the contractors are too. So up at the top, that says it has a main circuit breaker. It could also have a main lug only, which would mean there'd be no circuit breaker for the main, which can be, the code would allow this in some cases. That would not allow it, say for instance, as 120/208 panel board on the secondary side of a transformer. So like a 480 stepping down 208, 120 as a delta Y transformer. And for that reason, the code wants to have overcurrent protection here. There's a couple different exceptions to the ways you could do that, but mostly there's going to be a circuit breaker, and it's going to be within 10 feet of the terminals of the transformer, for the reason of that's a tap, and so it needs to have overcurrent protection and not go so far. The code doesn't want you to go too far before protecting. Inside the panel, there's bus, and the bus is then interconnected, as you see, kind of in a alternating fashion, such that the top breakers, being 1 and 2, are on the same phase of a 3-phase system, A, B, and C. And the next 3 and 4 are on the next phase, and likewise, all the way down, and it just continues. These panel board sizes are standard. Typically, they could be 30 pole or a really small number of poles being a breaker. 2 pole could be, so like for a range or your stove, or a water heater needs 2 hots, so that's a 2 pole breaker. So that would be a handle tie here, or like this C is handle tie for this is a 3-phase panel board. The panels can be fed through, so there could be another panel right next to it, and it's just wired through and connecting to these bus bars, and then having more breakers to expand the number of branch breakers, because after you get past 42, it starts to just be considerate. So you get up to 60, if you get up to 84, the depth of the panel board wire bending space just starts to be a little, and then considering these buildings, you're building a building that might want to be around 30, 40, 50, 100 years. So just using sensibility in this and knowing it's easier for the installers too, to try and split them up. But so this is one way to do that. You could also have a double lug. So potentially say there'd be a 100 amp feeder here or something, and then you come from here. And so this way there'd be maybe 2 main breakers. That's another way to do it. Down at the bottom here would then be all the totals of all the loads for each of the phases. And then the code doesn't make you size your service for everything that you connect to it, because that would be unnecessary. Because if you think to yourself, not everything in your house or otherwise in a building is operating at the same time, or even just situationally, right? So in the winter versus in the summer. There'd be heating or cooling equipment potentially running differently. So, and then you're not going to plug into every receptacle and use it, but the code provides the details of what the loads are required to be. So what you're looking at here in the top right is receptacles. So a duplex receptacle, so that has two places to plug in, is just on a single yoke, is 180 VA. A simplex receptacle, or a single plug place to plug in, is just one way to plug in, and that is only one yoke, so that's 180 VA. If you had two, that would be two of them in there, so that's 360 VA. So this is how the electrical code for receptacles allows you to presume load that could be anything that meets the NEMA or otherwise receptacle and plug configuration for the products that can fit in here. So there's a number of them that you can connect, for instance, to a 20 amp breaker or a 15 amp breaker based on that load. Lights themselves are just the load that they are. So just even residentially, you could put a different light bulb and they're a different wattage. So they are just added up based on that. But then the difference being that the lights are 125% loaded is what you do in the code, because they can be turned on for over 3 hours, and that would be a continuous load. So the code has you multiply have an additional 25%. So the consideration being that the wire is being heated up, and so continuously. So the product listings and all of that is in this mindset here of not letting fire happen, as well as these breakers are molded case with thermals, and so there's a physics involved in here of continuing to have current flow. So that's at the bottom, those would be added up. And again, panels closer to loads might have some. So for instance, if you had 10,000 VA, which is volt amps of load, or 10 kVA of receptacle load, the code wants you to take 100% of that, which means that you can't reduce your sizes of your wire or your overcurrent protection. And then after that 10 kVA, you can take 50%. So that helps. And then if you have a lot of panels that all have receptacles, and then you connect all of those to another panel, well, then that panel gets the benefit of this demand consideration, that there's how many receptacles connected to that panel now. Well, 100% of the 10 kVA, but then 50% of the rest, which might be a reasonable reduction. Okay, with regard to floor plans, this being just diagrammatic, the architects do much better job than the engineers for figuring out the walls and the doors and all the egress and the important aspects that we can't all think of. So, but this is showing that the floor plans would be like looking down. I think, again, this group is familiar with this. And the symbols being a place to look on the drawings to know what is being described.